Hi, folks. Welcome back. We are now at Module 3, which is going to be advanced regression modeling and also an intro to moderator analysis, which is a very cool extension of basic regression modeling. So this week we take a little bit of a deeper dive into regression, which is an incredibly versatile method that does a lot of things that can help us in our research. All right. So sometimes I'll add in a slide here about where we are kind of in the development of the course. And here we are at Module 3. You've now had a couple weeks of kind of working on um, learning R and or Stata and trying new analysis. And I noticed in the discussion boards over the past couple weeks, folks are starting to write about some of those feelings, right? Feeling pretty anxious sometimes when we learn a new program or software. In a lot of ways, it does sound like a new language. I think somebody mentioned that it is a little bit like learning a new language, and it can be really scary. And there is an element of kind of putting yourselves out there a little bit in learning something new. And those error messages are frustrating. I know sometimes when you get those red error messages, it's like, oh gosh, I did something wrong. And I get those too. So I would just say to that, don't sweat it if you feel that way, honestly. It is a totally normal part of learning a new method, particularly one that involves statistics and software. I like to use this analogy about a muscle, and consistent, regular, repeated practice builds up that muscle, your stats muscles, and help you feel more comfortable over time. And the more you do it, the more things will start to feel automatic. Now, if you do it once and then never come back to it, of course, you're going to have to brush up again, and there's that learning process. But I still look up things all the time in R and in Stata. I still get those error messages, believe it or not. They're still frustrating to me. Um, the stuff that I use a lot, regression or data management, cleaning coding, a lot of that stuff I do have memorized now, but that's after a lot of practice. And not everything will stick, and that's completely okay. And as I was reading about this, I was struck by there's an academic named Allison Hurst. I think she's in environmental science, but she is also an artist, and her webpage is linked here. And she made this really cool graph about learning R, which I think really applies to learning Stata or any kind of new stats program. So here, this is how much you think you know about the software, and this is time, and this is sort of the emotion over time, right? So it can be really anxious starting out, and then you start to feel really good, and then you probably hit some roadblocks, right? And then it drops down again, and then you learn a lot, and then you feel really good, and then it may drop or vary or change. And the key here, I like how her little people here, even though they're going up and down, they start to smile at the end, because that really is the mindset by the end. Is really, it's a learning opportunity, and there's so much you can learn about a software package and different statistical methods. The key is to take it one step at a time, learn a few new things, try them out, and then be open to trying new things when they come along. Uh, Point here, Allison mentions join the R community on Twitter. They're actually, if you're a Twitter person, there is a really, really vibrant and supportive and inclusive R community, way better than any stats package I've ever seen. So if you're an R person, there is a really supportive group of people out there who are ready to help on your journey. So stick with it. It just takes time. All right, so let's talk a little bit about advanced regression and moderator analysis. So I think it's important to probably start by laying out the difference between moderation and mediation. Yep, we need to start there, and this can be one of the most maybe frequently misexplained or misunderstood concepts in research design and methodology. So the concept of moderation is where we'll start first. So moderation is simply the combined effect of two variables on another. Combined effect of two variables. This is sometimes called in the statistical literature as an interaction effect. This concept is very similar to the idea of an interaction effect in an ANOVA design. It's actually identical. So when you test for an interaction in ANOVA, you are basically doing the same thing. You're actually looking for an interaction between two variables, in this case, two categorical variables. However, that's actually one specific case of a broader set of possibilities when we talk about moderation. So moderation is just sort of the general category under which that specific example sits. So you can have interactions between two categorical variables. That's basically like an ANOVA. You can have an interaction between two continuous variables, or you can have an interaction between a categorical and a continuous variable. The big idea I want you to take away with moderation is that where you are in terms of one variable can impact the relationship between a second variable and your outcome. Okay, so your position in one variable or your value or the score that you have here has a direct impact on the relationship between this other variable and the outcome. That's what we mean by moderation or interaction. It's essentially dependency. So here's a way that moderation is drawn a lot in terms of a path model. So here we have a predictor, and this big arrow here is pointing towards an outcome. And so essentially what we're looking at is the relationship. This would be like a simple linear regression. This would be the relationship between one predictor X and one outcome Y. And what a moderator does is it says, okay, that moderator imposes some conditions that impact the relationship between the predictor and the outcome. In other words, this relationship is not constant. It changes. This relationship right here, let me see if I can use my pointer. This relationship right here actually differs according to this other variable right here, which is our moderator. And that's why the arrow comes down and points to the middle of this black arrow here. So an example that we over here, this is a very broad general example, but let's say we have some sort of a curriculum or a set of lessons or a unit that we've developed, and we want to know the relationship between that curriculum and how much students are learning. One possible theory is that that relationship is not constant. In other words, the curriculum might be better for some people than others. For example, it might be more effective for folks from different SES levels, drawing on different prior knowledge or contextual background. It might be different for students of different genders, so on and so forth. So those are moderators. So they are conditions by which this relationship changes. So that is moderation. Compare that for a second to a mediation model. Mediation is a process. It describes a process by which one variable influences a mediator, which in turn influences an outcome. It looks very different. Notice for a mediator, we actually have an arrow that goes from the predictor to the mediator and from the mediator to the outcome. This is what's called the indirect path. And we'll learn about all this in module 12 when we talk about mediation. It's a really interesting topic, by the way. And then we have a direct relationship between our predictor and our outcome. So here's the difference. In a mediation model, we have a process. The predictor impacts the mediator. The mediator impacts the outcome. So it is a process, 1, then 2, then 3. In a practical example here with our curriculum, the curriculum might change a student's motivation. Maybe it gives them more self-efficacy or gives them a more positive attitude towards a subject. And that in turn also influences learning. So the curriculum might impact learning directly, but it also might impact learning by changing motivation. So that is a mediated relationship. Notice this is not moderation, right? So in moderation, we have no arrow going from the predictor to the moderator. So curriculum does not change. If motivation were a moderator, curriculum would not change motivation. It would just be a condition by which this relationship would be different. So very different. So there's no path and no process in a moderator, only in a mediator. A little more background on this. Many of you enjoy, and I recommend Jim McMillan's book, Fundamentals of Educational Research. And in the most recent version, I think it's on page 59, Jim has a really nice example. Whoop, go back. Jim has a really nice example of a definition that is of what a moderating variable is and a mediating variable. So again, for a moderating variable, a moderator increases or decreases the relationship between an IV and a DV. Okay, so a curriculum may be more beneficial for low SES students compared to high SES students. That's the example we looked at a couple slides ago. So notice the curriculum doesn't influence SES, right? It's just that people from different SES categories have a different relationship between the curriculum and the outcome. A mediating variable represents a process or a mechanism. It explains or describes how an intervention actually changes a dependent variable, right? So for example, a curriculum may be more beneficial for low SES students than high SES students. Oh, that's not right. What am I talking about? Hold on, stand by. So the example we want to use here is that, and I'll have this changed on the slides that you can look at. The example we want to look at here is that the curriculum actually changes someone's motivation. Someone's motivation actually then changes the outcome. And that is a mediating variable, and that is a process. That's actually a process. Okay, so we will study only moderating variables this week. We'll come back to mediating variables in module 12. So long story short, each one of those needs a different statistical tool. So you have to use a different process for studying mediation than you do moderation, where you can just use basic or advanced regression, but regression nonetheless. Okay, so I think it would be helpful to put this in more of a practical context. And so we're going to start talking about the data that we're eventually going to use with our software, but we're going to do some conceptual stuff at the front, kind of building up and looking at how this is a case of moderation and how it sort of functions conceptually as well. So there's this question in the sort of personality and social psychology research that's been going on for a while, decades actually, ever since video games were invented. And the question is, do violent video games cause people to be aggressive or antisocial? So if you play a lot of violent video games, is that going to somehow change your personality or your outlook in such a way that you become more aggressive and more sort of antisocial? And believe it or not, every time we get a new wave of video games, this argument pops up again and again, even with the early ones back in the 80s and 90s. Some of those had sort of violent themes, and that question was asked. And then again, as video games improved, right? And now we're in the world of like virtual reality and augmented reality and games that really kind of put you in that situation. And so this data come from a study in personality and social psychology that asks those types of questions, given a exposure of people to different kinds of video games, and if there was a relationship between that and their level of aggressiveness. So here we have a sample of teenagers, about 400 teenagers, and we have an outcome which is a validated aggression scale. Basically runs from 0 to 100. It's previously validated, and it's, you know, the mean score is right around, I think, 40 or 50 on that scale. So that's our outcome, is aggressive behavior. It is a survey scale, so it's not a measurement of actual behavior. It's more a self-reported scale of aggressive behavior. And then we have a predictor. In this case, our predictor is the number of hours that people report playing violent video games per week. So that's our predictor of interest. And then we have our other predictor, which is going to end up being our moderator. And that is a measure called callous unemotional traits. And it's abbreviated like this, CAUNTS. It's another previously validated scale that measures sort of antisocial personality, is essentially what it is. It's a personality scale. So higher scores here indicate higher levels of callous or unemotional thoughts or attitudes. So that is our setup. Now let's think about this conceptually. So what we're interested in is this fundamental question, which is, if you play more violent video games down here on the left, does that make you more aggressive down here on the right? So this is the fundamental relationship between the IV, independent variable, which is how much you play games, violent video games, and your DV, which is aggression. Okay, so what we're testing today is whether or not callous unemotional traits functions as a moderator. So notice the arrow here is coming down in the middle. We have callous unemotional traits. So what that means is, does the relationship between hours of violent video games and aggression differ for people who have different levels of this personality trait? So if you have a really high level of these personality traits, does the relationship differ than somebody who has a really low level? Notice it's not a process, although we could potentially test a process. We probably would need a slightly different design. But a mediation model would ask, so the arrows would go here, and game playing would impact callous unemotional traits. It would actually impact your personality, which would impact your levels of aggression. That's not what we're looking at here. Here we're looking at the case of statistical moderation and not mediation. All right, so this is one way to sort of visualize this relationship. What we're interested in, both of the variables, our DV and our IV, are both continuous. So here's our aggression scale on a scale of 1 to 100. Here's the number of hours playing video games. And we can plot each person in our data set, the 400 people, can get a point here that represents how many video games and how much aggression. And then we can actually fit a line for people who are considered sort of not callous based on the personality profile and those who are, and we can actually compare those two lines. And if we have moderation, then these two lines are not going to be the same, or they might not even be parallel. And that's what we have here. So notice, for people who are callous, we have a positive relationship between video games and aggression. So if you have that personality profile, the more you play violent video games, the more aggressive your behavior. But if you don't have that personality profile, there's essentially no relationship. So it's just kind of flat. There's no signal. So no matter how many video games you play, it does not have an impact on your level of aggression. So that's one way, a really useful way to visualize sort of a categorical moderator. If you have a continuous moderator, it gets a little trickier. You're essentially looking at some sort of a plane. You're fitting a plane through a three-dimensional space. I know I love these little three-dimensional space things. And you're trying to figure out if that plane is flat or twisted. If it's twisted, it's a case of moderation. If it's not, it's not a case of moderation. Just kind of a fun little visual there. Okay, so let's talk a little bit about how we do this statistically. So how do you actually test a moderator? And it's actually really easy to do. So we're familiar now. We've had our memory refreshed about what a basic regression model is. We've even run a basic regression model, a simple linear regression. And we've run a multiple linear regression where we have multiple predictors predicting an outcome. And so to add in a moderator, what you do is you create an interaction effect. And an interaction effect is simply the product or multiplying your predictor and your moderator together. That's all it is. So you have, here we have our predictor, our IV, here we have our moderator, and this is just the product of those two things. And we'll learn how to do this in software, but that's actually conceptually what you're doing is you're multiplying the value of one variable times the value of another for each person in your data set. That creates what's called an interaction effect. If that interaction effect is statistically significant, then you have moderation. It's not too complex really, right? So you're just creating an interaction effect and you're testing its statistical significance, its relationship to the outcome. In terms of a general model, oops, let me go back. In terms of a general model, we have an outcome y, which is equal to an intercept plus the impact of some predictor A, that could be our IV, plus some predictor B, that could be our moderator, All that's the same. We've studied that before in regular regression. Now we're just adding a third predictor, which is the product of A and B. And notice it's called AB. And that beta, that slope, is the thing we're testing to see if moderation has actually occurred. Another way to write this specific to our research question, level of aggression is equal to some starting level of aggression plus some beta for how much you play violent video games, plus some beta for your level of callous personality, plus some beta for the interaction of those two things, plus error. And that is a statistical moderation model. So only a little bit of a step from what we've done before. We're creating an interaction effect, and that's going to tell us whether or not we have significant moderation. All right, so I mentioned this before. There are lots of possible combinations of predictor and moderator, depending on what type of variable you're working with. And this is why I think this might be the most important distinction in all of statistical modeling, is to distinguish between continuous and categorical variables, because it really changes how you model them, how you handle them. So sometimes you have a continuous predictor and a continuous moderator. We'll look at that example. Sometimes you have a continuous predictor and a categorical moderator, and sometimes you have a categorical predictor and a categorical moderator. And we'll look at all three of those examples. It uses slightly different ways of interpreting the results, but the actual implementation in the model is the same. The best way, and we'll look at how to do this in both Stata and R, the best and easiest way to interpret moderators is with a visual. Believe it or not, graphics coming through again. You can run that test and you can get a p-value for that interaction, but actually interpreting that interaction is really, really tricky. You need a lot of practice with how the regression model works and what the betas are and what type of variables they are. But if you have that visual, that makes a huge difference, because it allows you to tell a story about the moderator that you might not otherwise be able to tell. And so we'll also practice with that as well. A couple other things I'll point out, but I won't spend a lot of time with. This is an example of the Stata output from moderation analysis with a little bit of an APA style write-up. So that's there if you want some examples of how that works. And this is what's called an interaction plot, which is the thing you use to sort of tell the story about the significant moderation. So that's something we work through in our demonstration. And I have the same thing in R. So here's the R output. And again, that same sort of APA style. And notice here, vid games times callus. That's actually the interaction itself. And we can look at that in Stata too. This right here, vid games times callus, is actually the interaction term that tells us whether or not moderation is occurring. And in Stata, there's a tool, or sorry, in R, there's a tool called interplot, a really cool package which allows us to do the same thing. We even get a neat little distribution, which I explained in the demonstration video, that helps us interpret the significance of our interactions as well. So I just want to say, before I wrap up this lecture, we are going to learn a little bit about centering variables. Centering variables is a really important concept. So anytime you're doing moderation analysis, it is considered best practice and highly recommended to center your variables before you conduct your moderator analysis. You only need to do this for your continuous variables. So if you have a categorical interaction, you do not need to do any centering. In fact, you can't do any centering, because centering only works with continuous variables. But centering is pretty easy conceptually. All it means is you subtract the mean from each value, each person's value on a given score. And so the mean goes from being, for example, 80, for example, or 75 in this case. So if the class mean is 75 and you scored an 80, on that centered variable, your score would actually be 5, because you were 5 above the mean. So it rescales everything in terms of the mean, and so 0 is now meaningful. The reason that we do this is to aid in our interpretation of the significant interaction. The intercept plays an important role in interpreting the interaction, and the intercept really is only meaningful when you center. And so we'll talk about that. I'll show you how to do it in the software, and we'll get a little more detail on that as well. And so just for reference, I have another output in here of the centered variables moderation analysis with a little description of what's going on, as well as the plot. Same thing in R. These are the centered variables, and here's the plot in R, just for reference. Okay, and last thing before I wrap up, this is just a really cool example that I found a few years back of moderation analysis, looking at opportunities for learning math in elementary school, implications for SES disparities in procedural and conceptual math skills. So this is a cool example of using SES as a moderating variable in the relationship between opportunities to learn and learning. So SES functions as a moderator. So those opportunities to learn that are provided to students function differently depending on the student's SES background. And it's just one example of how you can apply moderation into kind of a substantive question and get some really interesting answers. All right, so I think that's all I've got for the lecture section. A lot to cover here. And in the video section, the video demonstrations, we'll get into what this looks like in the software. So hopefully you found that helpful, and I will talk to you soon.